All right, we are on Unit 7 today. So we're going to talk about systems of equations first in this unit, and then we will move on to talking about matrices. Super duper exciting. So today is 7.01, and this should be completely review for you from last year in Algebra 2, where we did a system of equations with 3 variables. So we're just going to dive into 2 different questions of these. So we'll start with number 1, and then you guys will have some practice to do as well. So here's the original problem. X minus 2y plus 3z equals 9. Negative x plus 3y plus z equals negative 2. And 2x minus 5y plus 5z equals 17. So what I usually say is helpful to do is kind of just label these equation 1, equation 2, and equation 3 so that we can label our work and keep track of everything. One of the main ideas that I want you guys to focus on when you're solving a system of equations is that you need to get 2 equations. This is our goal, is to get 2 equations in the same 2 variables. So what I mean by that is if you get an equation that's in x and y, then you need another equation in x and y. If you eliminate the y, so you have an equation in x and z, you need another equation in x and z. So in a typical setup, that means you're going to have to eliminate that same variable twice. So if you eliminate x the first time, you need to eliminate x again the second time in your next system. So the goal is to get 2 equations in the same 2 variables. And then from there, you guys are usually good because you've done that in middle school, and most of you are pretty comfortable solving a system of equations in 2 variables. So we just have to get ourselves to that point. And there's a lot of different ways you guys could start this question. So what we're looking for here is just the easiest way for us to eliminate a variable. The first time, it doesn't matter which one we eliminate first. So right away, this one's jumping out at me because I see I have an x and a negative x, and if I add those together, they'll cancel out. If I had wanted my y's to drop out, I would have to multiply the first equation by 3 and the second equation by 2. So again, doable, but a little bit more work. And then for the z's to cancel, usually when we have a z with a coefficient of 1, that one's usually a little easier. Just like here, this x one will be a little easier, because if I wanted the z's to drop out, I would only have to multiply the second equation by negative 3. So remember, you want them to be, the coefficients to be additive inverses of each other, so that when you add the 2 equations together, that variable drops out. All right, so it looks like here, if we work with our x's, we can do that. Again, this is not the only way to do it. There's multiple ways of doing this. So I'm going to start. My plan is to eliminate the x twice. So I'm going to get 2 equations in y and z since I'm eliminating x. So let's first get our first equation in just y and z. So to do that, if I just add equation 1 and equation 2 together, these x's are going to drop out. Another thing I want you guys to remember is that you always should be adding your 2 equations. I don't want you ever subtracting them. So if you need to subtract, that means you just need to multiply one of the equations by negative 1 and then add them together. So always, always addition. So we're adding these 2 equations together. Now our x's cancel out. We have negative 2 plus 3y, or 3 minus 2 gives us 1y. This is 3z plus 1z is 4z, and 9 minus 2 is 7. I'm going to call this my equation 4. So now I have one equation that's in the variables y and z. A lot of the issues come with these when students just try to dive in and just start eliminating and don't have a clear plan. Really, really important to remember this goal. I need to get 2 equations in the same 2 variables. So now that I have one equation in y and z, I need another equation in y and z. None of my givens have just a y and a z. They all have x, y, and z in them. So I need to eliminate x again, but I can't do it. I can't involve this equation in my next step and I can't do equation 1 and 2 again. So I can do 1 and 3, or I can do 2 and 3. And that's really up to you. Neither of them are too crazy. So if you decided to do 1 and 3, you would need to multiply the first equation by -2 to get it to drop out with a +2. If you did 2 and 3, you need to multiply this by a +2. I'm going to do that. So I'm going to do 2 times equation 2 plus equation 3. All right, so first I'm just going to show you my work here. So I'm going to do 2 times equation 2, so that's -x plus 3y plus z equals -2. I'm going to distribute that 2 to every single thing inside the parentheses. So I get -2x plus 6y plus 2z equals -4. So that's 2 times equation 2. And then I'm going to write equation 3 underneath, which is 2x minus 5y plus 5z equals 17. Again, I'm always adding the equations together. And hopefully this seems familiar to you guys. So 6y minus 5y is 1y plus 7z equals 17 minus 4 would give us 13. So this I'm going to call equation 5. So now I've got this equation, which I got from equation 1 and 2, is in variables y and z. And this equation, which came from equations 2 and 3, so a different pair of equations, is also in just y and z. So now I'm going to take these two equations and I'm going to either eliminate the y or the z from them. So which would be easier, to eliminate the y or the z? Well, it looks like the y's both have a 1 in front, so if I just make one of those into a -1, I can add these two equations together. If you didn't see that right away, you also could, a little harder, but you could multiply this one by -7 and this one by +4 and get those to cancel out that way as well. So now step number 3, I'm going to multiply -1 times equation 5 and add it to equation 4. So here is going to become -y minus 7z equals -13. Put equation 4 underneath, so that's negative equation 5, C4. And again, I'm always adding the equations together. All right, now these cancel. We get -3z equals -6. To solve for z, divide both sides by -3. -6 divided by -3 is +2. So now I have z. Now I need to find x and y. So to find x and y, we don't have any equations in the original 3 that have 2 variables. All of them have 3. So now I only have one letter. I only know the z, so I need to use one of these 2 equations to find the next variable. So both of these equations have a y and z in them. It does not matter which one you choose. I'm going to choose equation 4, and I'm going to sub in z equals 2 into equation 4. And that's going to allow me to find y. So y plus 4 times 2, but it has to be into one of these equations with 2 variables because you can only find one thing at a time. And that gives us -1. So now I have 2 out of my 3 variables. So my last step now is to find x. So I'm going to sub in z equals 2 and y equals -1 into either equation 1, 2, or 3 because they all have 3 variables. I'm just going to choose equation 1 first. So I've got x minus 2 times -1 plus 3 times 2 equals 9. And then just simplify here. -2 times -1 is +2 plus 6. And I get x equals 1. And then finally, I want to write out my answer as an ordered triple, and that goes in alphabetical order. So x, y, z. My x is 1, my y is -1, and my z is 2. So this would be my answer. And to check my answer, I would need to take these values and substitute them in for all 3 equations, not just one, because sometimes it could work in one but not the rest. So make sure you sub in a 1 in for x a -1 in for y, and a 2 in for z, hit enter, and it should give you a 9. Do it again for the second equation, should give you a -2. And then for the third, should give you a 17. And you can do that real quick in your calculator. You can substitute it right in, or you can use STO. That's up to you. All right, so that is how you would solve this and check it. Let's do one more of these together, and then you guys can work on some on your own. So this one is 3x minus 2y plus 4z equals 1, x plus y minus 2z equals 3, and 2x minus 3y plus 6z equals 8. Again, maybe helpful to label these. I would like you to label them so that you can label all of your work. So E1, E2, and E3. All right, so again, our goal, let's write out our goal again, is to get two equations in the same two variables. Say that out loud so that you remember it. Really try to understand what that means. I need to get two equations in the same two variables. So if I eliminate x, I need two equations in y and z, so I need to eliminate x again. If I eliminate y, I'm left with x and z, so I need another equation in x and z. All right. Go through, see which one's the easiest. It looks like all of these are relatively easy to get them to drop out. So maybe I look at the x's first, so I see this has a 1x, so I could multiply this by -3 and add it with equation 1 to get the x's to drop out. I can multiply it by -2 and add it with equation 3 to get the x's to drop out. So I want to do equation 2 and 3 first. So I'm going to do -2 times equation 2 plus equation 3. And I'm going to just show out my work here. So -2 times equation 2. So I'll write equation 2 out. And then I need to distribute that -2 to everything, giving me -2x minus 2y plus 4z equals -6. So that's -2 times E2. And then I'll write E3 underneath. So 2x minus 3y plus 6z equals 8. Always adding the equations together. So we get -5y plus 10z equals 2. So I have one equation now in two variables. The two variables are y and z, so I need another equation in y and z, which means I need to eliminate the x again. So I already used equations 2 and 3. So 2 is nice because there's a 1 in front, so I'm going to do now 1 and 2. All right, so I'm going to do -3. And I feel like at this point you guys are probably good because we did do this last year too. So pause the video and see where that brings you. So -3 times E2 plus E1. So -3, I'm just going to write it out because you guys can do that on your own or pause if you need to. -3y plus 6z equals -9. Write out my E1 underneath that, which is 3x minus 2y plus 4z equals 1. Always adding them together, we get -5y plus 10z equals -8 for our equation 5. So now I have these two equations, both in x and y. So two equations in the same two variables. Both of them have a y and a z. I think I maybe said x and y before. I meant y and z. I eliminated x from both of them. All right, pause your video here and see if you can eliminate either the y or the z now. All right, so here I notice I've got a -5 and a -5. So if I just multiply one of these by -1, then that should drop out. So I'm going to do 5y minus 10z equals +8. And then I'll write equation 4 underneath, which is -5y plus 10z equals 2. Oh boy, 5y minus 5y, -10z plus 10z. So all of them cancel out, which means I'm left with 0 on the left side. And 8 plus 2 is 10. Is 0 ever equal to 10? No. So if you end up with a false statement like this, that means there is no solution. So we say that it's inconsistent. So there, sometimes what happens is when you do these, you might end up getting a solution for X. So I know some students have done this problem and they got X was like 7/5 and then 17/5. So you have to check to see that you can either eliminate a different variable to find out, or you'll see that you get two different solutions for X, which is not possible to have X be two different numbers unless you have infinite solutions, would be the only possibility for that. And that's what we're going to talk about next time. So if you do solve and you end up solving and getting an answer for X, or two different answers for X, you would need to eliminate a different variable to make sure that, to verify whether you have an inconsistent system or no solution for that one. And this one should be no solution, inconsistent, or I meant before inconsistent or infinite. And in this case, it is inconsistent, so we don't have a solution. So what that means is when we have three variables, they're planes instead of lines. So it could mean that those three planes are all parallel to each other. So they wouldn't have, they would never intersect with one another. All right, and then you guys next are going to have some problems to try on your own for more practice of these. Again, that should all be review for you. So hopefully it seems pretty straightforward, but if you do have any questions or you're confused on any part of it or just need some clarification, of course, just reach out, let me know, and we can go through it more together. All right, hope you guys have a great day, and good luck on your next set of problems that I want you guys to work on your own. All right, and pie out.